Okay, let's do this. So, we have a right triangle, right? And it has the property that the sine of one of its acute angles, so opposite over hypotenuse, is 3 times the cosine of the same angle. If the triangle is an area less than 375, what is the largest possible integer length of the hypotenuse of the triangle? Okay. Alexa, stop. Sorry. So if it's an area less than 375, then we know that 1/2 length let's just do opposite times adjacent is equal to 375. That also means that if you multiply this by 2, 600 or 750, so opposite times adjacent is less than, is it less than or less than? Yeah, 750. Okay. So yeah, that gives us something. But we want it to be the max possible length of the hypotenuse. We also know that hypotenuse is equal to O squared. Hypotenuse squared is equal to O squared plus A squared. So H squared minus O squared is equal to A squared. Square root of H squared minus O squared is equal to A. Then, yeah, never mind, I don't want to do that. There's no reason to do that. I'm just going to write H is equal to the square root of O squared plus A squared. Okay. You could also write here O is equal to 3A, getting rid of the H. Putting that in here, H is equal to the square root of 9A squared plus A squared. It's equal to A, take the A out, times the square root of 10, because it'd be 9 plus 1. Okay. So if the hypotenuse is an integer, then this has to be something root 10. A has to be something root 10. If A is something root 10, O is also something root 10. Just gonna write this out is equal to K, 3K root 10. Okay. So O times A is less than 750. Let's just make them equal to the highest thing we can. If we take, we can plug this in here, so we have 4A, because it's 3A plus 1A. Oh no, I lied. This would be 3A squared. is less than 750. A squared is less than, divide by 3 on both sides, you get 600 and plus 150, which is 250. Is this a square number? I don't think it is. Okay, now if I take a is equal to the square root of this, we get, what goes into this? 25 goes into this. This is 10 times 25 is less than 10, or 5, because the square root of 25, root 10. So let's say a is equal to goodness. Now I need the largest length of the hypotenuse. Let's say a is 4 root 10. Then O is equal to 12 root 10. O times A is 480 times 10, which is, wait, what? 480. This is 750. If I made this 5, this would be 15, which would be, ow. 5 and 15 is 750. Yes, it can't be that. So, I think this, do the side lengths have to be? The side lengths don't have to be. That makes no sense. Oh, because if these aren't integers, then this isn't an integer, I think. Okay. Right? Am I correct? I think I'm correct. Because if I do 4.5, then it'd be 0.25, and then I need to get 0.75, which I can't. I don't think I can get that. Yeah. Let me just think. Yeah. So if I say h is equal to, it'd be square root of 160 plus 120 is equal to the square root of 480. Wait, this isn't a square number. Oh, this is because that needs to be 100. This needs to be 1440. So it's equal to the square root of 1600, which is equal to 40. I don't know if this is correct, but let's see. Oh, it's 49. Can be modeled with a red triangle with lengths k and 3k. The Pythagoras theorem gives a hypotenuse length of k root 10. Yeah. Given the restriction on the area of the triangle, we have 1/2 k times 3k is less than this, or k squared is less than 250. This means k is less than 5 root 10. Therefore, 10... Oh. This was my answer, but it's incorrect. Therefore, k root 10 is less than 50. making the largest possible integer length of the hypotenuse 49. Okay, that makes sense. So what they did is what'd they do? They got here, and then they noted that the hypotenuse is equal to a root 10. So if they got it here, multiply both sides by root 10, you get a root 10, which is the hypotenuse, is less than 50. So the highest possible thing is 49. But I didn't get that one right. Thank you guys for watching. I'll see you guys tomorrow. Bye.